I hope all of you are practicing on the design, whatever we have learned last time in Excel program and RCDC also, I think. So we have finished with the RCDC and Excel part. So today we will discuss on the drawings, how we prepare the drawings for any project and what are the contents in the drawing. So in totality, we will try to understand. I hope all of you understand the AutoCAD and all these things, how to handle the AutoCAD drawings. Anybody who is not aware of the AutoCAD software? Anybody? Because today's session is not for AutoCAD, it is for structural drawings. Please try to understand. And those who are not yet done with the AutoCAD software, we will do the sessions. Don't worry about that. But generally, people are aware of the AutoCAD in general. So anybody who is not conversant with the AutoCAD? कोई है क्या जिसको AutoCAD नहीं आता, मतलब या पता ही नहीं कभी? So in the beginning, we have learned how to design the footings. One is by using this kind of Excel programs or Excel sheets. And secondly, we have learned to do the design in RCDC software. So for any projects, there are different types of drawings which we are supposed to do. For example, if you see this, you have already done this G+5 building or P+5 building, we can say. So this is a parking first, second, third, fourth, and fifth floor, right? So this was the problem statement we have taken in our training program. And so finally, we need to submit the drawings to the site for construction. So if you want to submit the drawings to the construction, what kind of drawings we generally submit to the construction? Anybody knows? What type of drawings we consider?
Architectural and structural drawing.
Yeah, architectural and structural. Yes, this is we can say in totality. Now, what types of drawings we submit in structural part?
So design of footing.
Yes, so we submit foundation drawing or footing drawing, whatever you say. So as we are having what we are having in our building, so we are having. So let's say this is your fifth floor, fourth floor, third floor, second floor, and first floor, and parking. Okay, so this is our drawing. And whenever I say parking, this is your parking, and below that there is a foundation. So generally, we have a ground level like this. So this is your ground level. Then this is your parking or plinth level, we can say. This is plinth. Then this is your first slab. Then this is second slab, third slab, fourth slab, fifth slab, and sixth slab or terrace slab, you can say, whatever. So these are the floors, and there may be one staircase cap is also there. All of you know that there is a staircase cap. This is a staircase final, we can say staircase. So this slab is staircase cap slab. And many times we are having a water tank above this. So there will be water tank also. Overhead water tank, OHWT, overhead water tank, which is generally covered from the top. Now, if this is our problem statement, you know, I think this maybe. Okay, now tell me what kind of drawings we submit to the site so that they will do the construction on site. So first will be our construction starts from the foundation, that is from the bottom to the top. Okay. Generally, whenever we do the analysis and design, we start from the top actually, but the construction is from the bottom, that is from footing level. So first drawing will be which?
Foundation layout.
So it will be foundation drawing. Foundation drawing. Then second one,
Plinth drawing. Footing.
no, column drawing. Don't forget, because on the foundation there are columns. So column is the, so column drawings, because we start the columns from the footing itself. So column drawing is first. Then third one,
Beam drawing, sir.
so beam drawing, but that too at the plinth level. So plinth level drawing.
Plinth
So
beam.
so plinth beam requires, see, this drawing contains plinth beams. Yes. So plinth beams schedule. So what size of the beam should be taken, then what is the reinforcement. And also all of you know that we start the staircase from this level only, right?
Yes, sir.
So this is your staircase level like this. Okay. So we should give the staircase drawing also at this level only. Then and then the people can start the construction, right? So here also we start our staircase also, and then staircase goes, and even maybe there is, if there is a lift in the building, okay. If there is lift in the building, it starts from plinth level or where it starts. Anybody knows where our this lift wall starts? लिफ्ट वॉल कहाँ स्टार्ट होती है? अभी ये तो मेरा स्टेयरकेस है समझो. So this is your staircase.
Opposite to the staircase.
Okay, so let's say I am having a lift over here, just beside this one. So this is my lift area, this one, middle portion. Okay, so where it starts? It starts at the ground level itself, foundation level here. So I will have footing for lift also here, and then I will have a lift pit. Okay, that means it goes below the ground also. So our lift starts at the ground level or at the footing level. So this is your footing for the lift. That means in column drawing, we need to give the details of lift pit also. Lift pit. So column drawing contains column details, reinforcement sizes of the columns. Till the top, all the columns are starting from the ground and till the top, till the terrace level or even above also, if there is a staircase and overhead tank. So these are the drawings and plinth level. Okay, is there anything else? I don't think so. There is much. If there are any underground tanks, generally, if they are within the building area, then you should give the underground tank details also. If they are within the building, or they may be outside the building. Let's say there is a water tank here, underground tank over here, like this. But as whatever is the underground construction part, we should give all the drawings at the below ground level, whatever. So below ground level contains footing, columns, lift foundation, and water tanks. So let's say this is your water tank, UGWT. So this is also required in any construction. Once you are done with the underground part, then you start the superstructure. So this below ground portion, we call it as a substructure, and the above the ground level, we call it as a superstructure. Okay, superstructure. So this is below part, we can say, and yes, below plinth level is above the ground. So this will come over here. Then again, then we start with the first floor or first slab drawing. So you can call it as a first slab, or you can call it as a first floor slab also, whatever you want to say. But this is the location, first slab layout. And schedule means schedule of beams, schedule of slabs. So what is there in at this level? We are having beams also, we are having slab also at this level. Then sixth drawing will be second floor or second slab. Then third, fourth, fifth, sixth, and terrace. So let me just similar to that, and final will be terrace. And after the terrace, we will have staircase cap slab. So there is also slab for, and then ninth will be the overhead tank details. OHWT, overhead water tank. So this is the finishing of the project, we can say. So almost we can say how much drawings are there. So second, then third. So generally, if the second and fourth are same, then you can say second and fourth. Then there is a third, first and third. So 1, 3, 2, 4, and terrace. So this way also you can do this. Okay. So how many drawings? Almost 9 to 10 drawings are there, which we need to submit to the site. So this is this we call it as a deliverables. Generally, we use this word deliverables. So it helps you to plan your work also in the office. If say this is a project and you should know what is their foundation stage. Say in bar chart, they generally mention the dates also. So they expect that foundation drawing should be received, let's say on 1st of August. So they will start their construction. Then they will expect the column should also received on 1st of August. Then they want plinth beam at, let's say, maybe 15th of August, whatever means. So generally they can plan construction, and we can also plan our work. So when to start our ETAP modeling, when to prepare the design basis reports. So all this planning can be done on the basis of these deliverables. So deliverable is very much important. And finally, this is the final output actually, which we give to the site. And I generally suggest all of you, please focus on the drawing part more. So even though you have little errors in the design or analysis, doesn't make much difference, but don't do any mistakes or errors in the drawings, because finally the construction is based on the drawings only, structural drawings. So these are the types of drawings. So today we will discuss on the foundation drawing. So we are having this. So we have done what we have done. We have done the model. Rather, we have prepared the structural GA drawings, where we have decided the column positions, slab positions. Then we have finally we prepared the model. Then we have designed the footing in Excel or RCDC, whatever you want. So if you do the design in RCDC, let me tell you. So how we prepare the foundation drawing. So whatever general arrangement drawing we are having, generally you can see this. We have decided these column positions in the beginning of the projects, and we have finalized these column positions and orientations from the architect, and we got this. Now this drawing we have done in the AutoCAD software. So you can copy this column block, and we get this block here like this. All the columns are here. We don't take the drawings of the layout from RCDC directly. You should prepare the drawing in AutoCAD. Okay. You can copy the schedule of footing from the RCDC as it is. There is no problem. But whenever you prepare foundation layout, the AutoCAD drawing is essential, because it is exact. We are having exact dimensions as per the architectural drawings and structural drawings. You can see here, these dimensions are very much important for center line of the columns. See, whenever we prepare any RCDC model, RCDC design and drawings, they are based on the ETAP model. And all of you know that whatever ETAP model we are preparing, it is approximate. Do you agree with this? ETAP model dimensions are approximate. Yes?
Yes, sir.
Because we assume certain center line like this. This is a column. Then we create a grid like this. Not necessary that your grid is exactly match with the reality. So dimensions are approximate. But see, we cannot do the approximate construction on site. On site, it should be accurate. So site is very much important. So site should be accurate. That means drawing should be accurate. So drawing should be as per architectural drawing. That means you must use AutoCAD for drawing preparation. There is no other way. AutoCAD gives exact dimension as per architectural drawings, because we have done, or we have prepared this structural GA on AutoCAD itself. So for example, you can see here, I think is it there? Can you see this? The gray color portion is the architectural layer. So, and we have also developed this beam layout and column layout exactly on the architectural layer. So everything is clear. You can see this outer line is just matching with the column. Then our beams are also exactly above the walls, not above the walls, below the walls, we can say. So each and every dimension is accurate dimension here on AutoCAD. That's why I am taking this column positions from the AutoCAD itself. Now what you get, so either you get foundation sizes from the RCDC. So you take the foundation sizes from the RCDC and just copy that on the layout. Okay. So you know how to prepare this layout. For example, let's say your foundation size required for the design is 1.55 meter by 1.9 meters. So 1900 by 1550. So either you can draw this like this, and then draw this. Then you give the offset. So this is also one way. This offset is generally 100. Okay. And then take the center of the footing here like this. So let me assume the center. I'm just drawing this diagonal for center, and then move this whatever you have drawn. Now this my first column footing size is this. So let's paste this on this column layout. Okay. And then remove this diagonal. It was only for reference. And then you can give the dimension to this like this. So in the similar fashion, you can put all the footing sizes on this, correct, as per the design. Either design may be from Excel. So see, we have done the Excel design and we have put all these footing sizes, and finally we have checked the shear check and bearing pressure and so on, all these things. And we have also arrived at a reinforcement schedule. So we get the reinforcement along L and along B. Finally, we must have the calculation which are safe here. So there is some problem over here. So once the design is safe, then what we do? We take this size, let's say 1.4, or our size is now 1.9. Let's say 1.9 by 1.55 is safe in our case. Draw this. Once it is safe, then you just should draw like this. So similarly for all other columns, design the footings and paste this size of the footing on the plan, and you develop such kind of foundation layout. Okay. And there is one other way. You also get the foundation layout from the RCDC software. So from RCDC also you get ready-made rectangles like this. So you can paste that rectangle on these columns. That is also one of the shortcut way by which you can do. But I generally, as a beginner, I suggest just draw the rectangles and paste here one by one. I know it will take time, but okay, you are learning mode, so do that. So finally, what you will get these foundation layout. All the dimensions. What is this dotted line? Anybody? Can anybody tell me what is this dotted line?
PCC.
Yes, it is a PCC. So if you look at the foundation, here you can see. Can you see this? This is the section of the footing, right?
Yes, sir.
And here you can see there is a PCC below the footing. So we generally provide PCC below the footing. So this projection, whatever you can see here, this projection is generally 100 mm or 75 mm or 75 mm. So this is the PCC projection which you can see in the plan, right? So that dotted line is nothing but a PCC. So your foundation layout is ready. Now you need to design the footing also for lift wall also. So you can write, say, take the loads of the lift wall, and then you can put that like this. It may be anything, I don't know, like this. Okay. Your foundation layout is ready, and you can name this as a footing layout. I think in the morning, Bansal sir is there. Is it in this batch or other batch? Okay, no issue. So you can give the name to the footing layout. AutoCAD training हुआ है क्या आपका सभी का?
मैं तो कर रखा है सर.
किसका बाकी
Yes,
रह
sir.
गया मैं? But generally you are aware of the AutoCAD? पता है ना सभी?
Yes, sir.
Yes, sir.
हाँ, तो मैं क्या बताता हूँ? See, whenever you prepare these drawings, we are having standard drawings. यहाँ देख सकते हैं कि standards are there. This is as per our company standard. So you need not to develop each and everything again and again. See, whenever we learn AutoCAD, we learn from how to draw a line, how to draw a rectangle, how to put the colors to the lines, and so on. See, once you know the AutoCAD software, forget it. You can use its shortcuts. So see, we have developed these standards where you can say, let's say this is a plan. So you can copy this as it is. Go there in your drawing. Let's say I don't have anything over here, for example. Let me move this. Now I have just copied this and I want to give the name as a footing layout here. Okay. So edit this ED and enter. And here in plan, I will write it out as a footing layout. Footing. So you can directly use the standards and prepare the drawings. Even these dimensions, whatever I have done, say, let's say I'm drawing a rectangle here like this. And I want to give the PCC also. Okay. And you can see now PCC is below the footing level. So it is shown as dotted. So if you want to make it dotted, this line, outer line, then you can directly match property. You know, this is a brush, match property brush.
Yes, sir.
Just click over here and then click over here. So the drawing preparation is very, very easy actually. So no need to prepare a dotted line separately and then just match the things, copy, paste, match. So as a smart draftsman, you should know how to use the available data for our purpose. Okay, so this is very much important. So once you have all these standard drawings with you and standard details, you can quickly develop any drawing. So there is no much we can say very complex things. It's very easy to do, prepare the drawings. Just use the existing drawing and just match it and copy paste it. So this way we can do the drawings. So we are having all the standards. I will just show you the standards. We are going to share these details with you also. So if there are beams, dotted beams, then you can match this with the dotted line. So these are the beam, dotted beams. Then these are the beam numbers, beam sizes, then column numbers, then one-way slab, two-way slab. So they're ready-made. Just copy it and paste it. You can just copy like this and paste wherever you want. Okay. Then there are this detail names, section, plan, elevation, detail. Then section mark like this. Section 1.1, section 2.2, or section 4.4. Then details, clouds. Then we are having dimensions given in for reinforcement actually. Then there are dimensions 1:100 scale, 1:50. So then level marks, then bolts, then break line, levels. So everything, all details and grid lines also, they are given in here. So you can directly copy this and paste wherever you want, or you match it. So in foundation drawing, we have a footing layout where all the sizes are mentioned. The sizes we got from the design, either Excel or RCDC. This is first part. Second part is the schedule of footing. Schedule of footing means the numbers. Yes.
सर जो स्केल मेंशन किया है वो सिर्फ प्रिंट आउट के लिए रेफर करते हैं या फिर ड्राइंग में कुछ उसका रोल है सर 1:100 ऐसे?
Yes, see, printouts. Generally, scale is for printouts. So whenever you take printout, so there are different pages for printing, A2, A3, A4, A1 like that. So once you print it, do you know what is meant by 1:100? Okay, you have asked the question. Anybody knows what is 1:100 or what is 1:50? पता है क्या किसी को?
Size of scale.
Drawing में 1 centimeter.
Yes.
Sir, ड्राइंग में 1 सेंटीमीटर है तो साइट में 100 सेंटीमीटर.
Yes. So 1 is on the drawing and 100 is on the site. So if on the drawing it is, let's say 1 mm, so on the drawing it will be 100 mm. So keep the unit same. If on the drawing it is 1 centimeter, on the site it is 100 centimeters. So on the drawings means after printing. Whenever I say on the drawing, it is on the printouts, not in the AutoCAD. AutoCAD is a infinite space having any dimensions. See, it is something. Do you know what is AutoCAD? Means whenever we draw on AutoCAD, what scale we are getting here?
1:1.
Yeah, 1:1. Or I would say, do you know this black screen is there? There is a big black screen in AutoCAD. Generally, we call it as almost infinite space. Almost. That means you can create a plan of, we can say, let's say Indian country. Such a big plan. That means there is a big space available in AutoCAD, virtual space we can say. That means you can directly draw the drawings in AutoCAD as good as you are doing the construction on site. So this is a real, okay. So you can draw on 1:1 also, there is no problem. But whenever you print, it cannot fit within the print. And that's why we give the scale. Do you know why we give the scale as 1:100 or 1:50? Because actual size cannot be fit within the drawing. And that's why we are reducing this, or we are dividing by scale. So how we prepare the drawing, for example? Okay, yeah, important topic actually, generally. Let's say I am having a drawing of size, ये समझो quickly ये करेंगे drawing scale का मत. अभी generally let's say I am having a page size 210 by 297 mm. I think all of you use this page in office generally. ये पेज है हमारे पास समझो. अभी इस पेज पे हमें एक ड्राइंग निकालना है. लेट्स से आई वांट टू ड्रॉ एक ऐसे रेक्टेंगल है समझो. लेट्स से दिस इज अ प्लॉट है समझो मेरे. दिस इज अ प्लॉट ऑफ माय हाउस लेट्स से, एंड प्लॉट साइज इज लेट्स से 15 meters by 30 meters. Okay, just take an example of this. So this is my actual plot size on ground. So I have my plot and I want to construct let's say house. So I will have a house over here. Now tell me, if you want to draw this rectangle of plot, let's say this is a plot layout, and if you want to draw this plot rectangle on this page, what scale you will use? First of all, can you draw 15 meter line over here? 15 meter मतलब कितने mm है? How much mm?
15,000 mm.
15,000.
30,000 mm.
And here 30,000 mm. So why
Yes,
I am
sir.
taking this? Because my page is in mm here. Now this is your plot dimensions. 15,000 mm and 30,000 mm. Now can you draw a line of 15,000 mm here horizontally? Can you draw this?
No, sir.
Because कितना है हमारा? Only 210 है.
200.
तो अभी हमें क्या करना पड़ेगा? I want to reduce this by scale factor.
Yes, sir. 1:1000.
1:1000.
1:1000 sir, reduce increase करना पड़ेगा ना अगर उसमें करते
Let's say I take 1:100, मतलब 100 से divide करता हूँ मैं इसको. Whenever I say 1:100, so I need to divide this by 100. So कितना होगा? 15,000 divided by 100.
150.
So it will be 150 mm. Can I fit 150 in this?
Yes.
ये तो 210 है, तो कर सकते हैं ना?
Yes.
Start कर रहे हैं. Let's try it. See, there is nothing.
Yes, sir.
Let's say I can fit this line because this is my 150 mm line here. Now there is second question. What is this? Now scale is same, huh? Don't change the scale. Now this 3,000 will be how much here? Sorry, not 3,000. 30,000.
300.
So
300.
this 30,000. ये कितना है? Divided by 100 will be 300 mm.
Will be 300. Yes, sir.
And our page size is 297. It is less than-
297. Yes,
so it
sir.
cannot fit. नहीं होगा ना इसमें fit.
नहीं होगा सर.
Yes, sir.
So then change the scale. So what scale you want then? Let's make it 1:200.
150 also.
150 ले सकते हैं अभी मैं just simplicity के लिए. You can take 150 also and try it. Generally scale, whenever you use the scale, I generally recommend to use the scales 1:100, 1:200 if they are bigger. And if they are smaller, then you can think of 1:25, 1:50, 1:10, 1:5. Okay, so and 1:50 also you can use exceptionally. Why I don't use this scale? Because generally we need to do the calculations whenever we put the scale on the drawing. Okay, or there are some
Yes.
triangular scales are available in the market. All of you may be knowing this triangular scales. So this is the cross section of the scale. So you are having different scale over here, different scale over here. Almost 6 scale you get. Have you used any triangular scales? स्केल मतलब हमारी जो स्केल रहती है ना 1 फीट की 300 mm का स्केल रहता है ना हमारा, तो इंस्टेड ऑफ दैट वी आर हैविंग अ ट्रायंगुलर स्केल एंड इसके ऊपर ऐसे ये रहते हैं मार्किंग्स. ओके, लाइक दिस. So this marking is for 1:100 scale, this marking is 1:50 scale, like that we have this. So let's say you use the 200 scale, then that means ये कितना लाइन रहेगा मेरा 15,000 divided by 200. So 15,000 divided by 200. How much is this? 75 mm.
25.
Yes, sir.
And if you take 3,000, then it will be
200.
150 mm. Okay.
Yes sir.
So that means I will draw this line. So now this will not be 150 mm. So it will be 75 here on paper. So let's say I draw a line of 75 width like this. Let's say I will draw like this 75 width. This is 75 width and this is 150. So if I measure on the paper, see this is a paper, please imagine this, that you are working on the paper using pencil and scale. Huh? Don't forget. Now you have drawn this line. How much is this line? 75 mm. By using your scale, that 1 feet scale whenever you use. This is your 75 mm and this is your 150 mm. Yes. Whenever you draw it, but whenever you draw it, we don't write down the dimensions which are scaled. Okay. This is only for understanding. So we write here as, okay, let it be. So what I will write here? I will write here 15 meter only. Okay. This is 15 meter only. Whenever I draw any dimension on the paper, it is side dimensions, 30 meters, let's say, or 30,000 mm, whatever. So this is my side dimension. And whenever I say here plan, I will write over here as a 1:200. Okay. Now, if you put the scale on the drawing, this paper, then how much dimension you will get here on the scale? So you see, we are having a scale like this, 1 feet scale. So this is 1 centimeter, 2 centimeter, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 30 centimeters actually. Let's say this is 1, 2, 3, and this is 30. Centimeter means 300 mm. 1 centimeter means 10 mm. So please use consistent units. Now, if you take this scale and you measure this dimension on the paper, you will get, how much you will get this? Something 75 mm. Yes, this dimension. In real, so if I ask you, if I don't give you this dimension, let's say, for example, I'm not giving any dimension to you. I have only drawn the rectangle here and I have written here as a 1:200. Can you tell me what is this dimension? On site. Here I'm writing 1:200 and here I'm not giving any dimension and I'm asking you, please tell me the real dimension on site. So what you will do?
Multiply.
So we have
You-
to measure it by scale and then
First-
we have to calibrate it.
Yes, so you can measure it by scale. Let's say this is your 75 mm paper dimension. This from here to here, it is a 75 mm on the paper. And what is this scale? 200. So multiply by 200.
1:200.
200.
So
Yes, sir.
200 से multiply किया तो it will come out to be 15,000 mm.
15,000 mm.
So this is nothing but 15,000 mm. So this way you can see many times we print on the paper correct to the correct scale. Then even though see many times what happens, we don't get the dimensions of all the objects or lines. And if you are in a confusion, what is this dimension? Then you can directly measure it by scale and multiply with this scale. Okay, so you get that dimension. So that is the use of this scale. So I hope this concept of scale is clear.
सर हम AutoCAD ड्राइंग बनाने से पहले ही पेज का साइज डिसाइड करते
Yes,
हैं.
yes. See, either you can see. Let's say I don't have this layout, for example. We say whenever I start any AutoCAD, let's say now this is without any page. You can prepare all this schedule and layout and all these notes and everything, and then you can have different sizes of the papers. So there are different sizes. This paper size is A3 size. So let me take this A3. Let me copy this first. Okay. Let's say this is your A3 size. This is your A3 size. Let me take it out. Then this is A1 size. Okay. You should have the sheets also, standard sheets outside. So this is your A1 size. And there is one more size, which is, I think this one is A2. A2 hai kya? A2 tha. Let's say you are having the sizes A1, A2 and A3. So these sheet titles are already there with you. Now, once you prepare this drawing, arrange this and just move this object. So let's say I'm copying this A3 size here. And if you take it here near to this, you can understand that it cannot fit in A3. Can you see this? So objects are going out of the page. That means this
Yes,
drawing
sir.
cannot be fit in the A3 size. Now again move the A2 size. Let me move this A2 size and just go there and can you fit that? Check it out. And it looks that it will fit. If I rearrange this, let's say this way you can do. And if your other, even though it cannot fit in A2, then you can copy the A1 size also. So this is your A1 means bigger size. And you can see here. So here actually I can fit it in A1 also, you can see here. But I generally don't recommend because see there is an unnecessary blank space which is there. So you are not optimizing the paper space. So that means A2 is a good choice than A1 because A1 is carrying unnecessary empty space, right? So better we put the A2 here. So this way we choose the sizes of the paper. So you can either prepare the drawings and then decide the paper size, or you can think of paper size in the beginning also, but it's up to you. Better way, do this first and then put the papers. And you can have a choice that if you are not comfortable with A3 size, A2 size paper, then you can have A3 size paper, but you can split your drawing in two parts. For example, let's say this is your A3 size, which is smaller size. Let's say this is your A3. So what I will do, I will split the foundation drawing in two parts, in which the layout I will put in one drawing. Let's say I will put this layout in this drawing. Okay. Then let's say can I fit the schedule in the this one? Let me check it out. You can think of putting the schedule. So can you fit in this? And if you are not able to fit in this, then you can put the schedule in some different sheet like this. Then you can put all these column details and then you put here somewhere. So you can split that into different sheets also. One drawing. See, now this drawing is very smaller project. There are a lot of big projects also we are having in reality. So for bigger projects, you need to give the A1 size papers. And if they are not fitting, then you can even split that drawings in different sheets. So many times, see, let's say this is your layout. Let's say my building is such that the width of the layout is like this. So long building. Even you cannot fit in A1 size. In that case, what we do, we split that building in two parts. Because there is no other choice. I don't have the paper. Either you can reduce the scale, or if you are not in a position to reduce the scale, then split the building in two parts. And here what I say, there is one point here. Okay, there is one line type over here, match line. Can you see this? So this is your match line. So whenever I will take A1 drawing first, let's say, or ये drawing लेता हूँ मैं for A2 है क्या? Okay. So first of all, let me check whether I can fit. So no. In two drawings, you put the building. In one drawing, what I will do, I will say, let me trim this first. Let me copy this. I'm trimming this right portion, and I will put this left portion in this drawing. And in the other drawing, I will put the right portion. See, you can see here. This. And here you can say this is a match line. So whenever you take the printout of this and this line and this line, you should match it on the paper by folding the paper, and then you will get the whole layout. Getting this? So this way we can handle the page sizes whenever we prepare any drawings. Okay.
Yes, sir.
Yeah. So let's go to our layout again. Back to this. Now we have a footing layout in the drawing, foundation drawing. Then we are having a footing schedule. We need to mention the grade of steel and grade of concrete also here. And we also have a footing numbers, FC1, FC2. So generally, let's say this is your C1 column, C1, C2, C3. Or do you know the numbering system? The numbering, we start from the top, from this corner, 1, 2, 3, 4, then 5, 6. So it will go on horizontal line. And the one which is coming first will be the number. So this way, and you should give the numbers as FC1 if it is a C1, FC2 if it is this. For this, you can give the name as, let's say, lift pit wall, so LFP or whatever you name. So these are the numbers of the footings or labels of the footings. We can say FC1, FC2, FC3. This is your footing numbers. Then column numbers. That means the column which is resting on this footing. Let's say this is C1. Now footing type means pad. So there are footing types. All of you know pad footing means box footing, in which the depth is same at each section. Do you know this pad or box footings? So this is your pad footing. So this depth is constant at any section. Then see, this schedule we are getting in the RCDC. Yeah? We are just copying this here, but you should know. Then length and width, LB of the footing and depth of the footing. Say let's say 1900 by 1550, 475 is the depth. Then there is a reinforcement return, footing reinforcement at bottom, along B, along L. So along B, along L, do you understand what is this? Here you can see. If this is the length of the footing, this is width of the footing, then along L means which footing? Tell me. Along L कौन है? Horizontal or vertical?
Vertical.
No, along the line. Along L means along L, like
Horizontal.
horizontal only,
Horizontal.
along. So this reinforcement is along L. It's horizontal along L. This is along L and this one is along B. Okay, please. So these words are important. See, I know that many people may get confused along and across and this. Better you should know which direction you are expecting. So you can write over here itself. So as it is a length, we can call this along L reinforcement as a longitudinal reinforcement. And this along B means you can call it as a transverse reinforcement. But I generally don't use. You can use along L and along B. It's very simple. And at the bottom. Generally, we get the reinforcement at bottom only for isolated footings. And if there is any remark, you can write down the remarks also over here. So this is the schedule, and you can see the details. If you draw the section, it looks like this. So here you can see along LC. Let's say this is your length of the footing, total length of the footing. Then this is a longitudinal reinforcement, and whatever dots you can see over here, they are along B reinforcement. Okay, these are the dots. Whatever is the spacing. Let's say this is your T10 at 200 center to center, which is nothing but my along B reinforcement. And this is your longitudinal reinforcement. This one. Let's say this is my T12 at 200 center to center, which is nothing but along L. So you'll put the reinforcement accordingly. This is your depth of footing from the schedule. You can get this. This is the length of the footing here from here to here. Thickness of PCC generally we take 75 mm. So what we are mentioning in the standard drawing, these are the drawings. And there is a L to the reinforcement. L means generally we develop this by this L is we can take comfortably total depth minus cover. So ये कितना आना चाहिए? Either you can mention normal say 200 or 300, this one, or you can mention total depth also. There is no problem. Okay. So this is the generally development length actually from here to here. So you need to give it standard 200 to 300. You can give it comfortably for footings. Okay. Because even though we know that how to calculate the development length, we cannot give the development length separately for each footing. So generally we standardize these L values, development length values. So this is 200 or 300 you can take. So this is your standard drawing for the footing. And we start our column from the footing. So all of you know this. The main reinforcement of the column starts from the footing. And we also take this L of the footing, say column reinforcement as 300 minimum. So can you understand these drawings, section of the footing? समझ रहे सभी को?
Yes, sir.
Yes, sir.
Yes, and let me go over here. So let's say this is your ground level. Where we rest our footing? Where do we rest it? So we excavate and we are resting on the hard strata. So this level is your hard strata. Yes. So whenever you take a test pit on the site, or if you do the geotechnical investigation, we get these levels. Let's say your hard strata is 2 meters below the ground. So your foundation depth is 2 meters below the ground. And hard strata is having some SBC. So you get this SBC. Let's say you are having a geotechnical report. So you will get at 2 meter depth below the ground, you are getting SBC as 300 kilonewton per square meter. Okay. Either you get it through geotech report or you can assume it. If you visit the site, take test pit on the site, and if you are sure about SBC values, if there is a hard murom or something, you can assume such kind of SBC values. So this is the level of your foundation. that means you should mention this on the drawings. So we mention the SBC values on the drawings in the notes. So have you got this the schedule and its significance with respect to the section? Iska meaning samajh mein hai?
Yes, sir.
And how we are putting this reinforcement in the section. Now let's go into
Yes, sir.
the notes. So we are having a lot of notes in the drawings. Whenever we prepare any drawings, the notes are generally there in the drawing. So first note, you can see all dimensions are in millimeters unless noted otherwise. Okay. That means all these dimensions are in mm. You can see 2150 is mm. This is general practice. We generally give this dimension in mm. And in case of discrepancy, dimensions mentioned on the sanction architecture drawing shall be followed. So if you are finding any difficulty in dimensions, please call the consultant or architects to understand the dimensions. It is possible that many times we don't give any dimensions. So in that case, instead of assuming on site, see, I'm asking you, if you are a site engineer or a contractor, don't assume anything. Please ask to the consultants or architects, whoever is the right authority at that moment. So discrepancy mein assume mat karo. See, many times we have seen that the people assume something and then do some mistakes on site. Then all materials and methods of construction shall be as per IS 456. And 8 mm and above reinforcement shall be of HYSG, that is high grade steel, right? Tor steel we can say. And grade is Fe 500. So we are mentioning the grade of steel over here. And reinforcement shall conform to the ductility requirements. If you are designing for earthquake, you should follow this code. Then all structural concrete below first slab level shall be of grade M20. Okay, so grade of concrete is M20 minimum, and then size of the aggregate 20 mm minimum. Cement content, see, these are the standard notes, but whenever we do any concrete, M20, M25, you should do the mixed design actually. Okay. And once you do the mixed design, then concrete grade is achieved. So we are giving the standard details actually, minimum cement content as per code 300 kg per m cube. Then water cement ratio 0.5 maximum. So all these things, and it shall be machine mixed. So you should use the say mixer for this, preparing the concrete, either site mix or ready mix concrete, RMC. And mechanically vibrated and properly cured. So you should compact it using vibrator, and curing should be done at least 7 to 10 days for the concrete. So these are standard notes. And foundation shall rest on hard strata, having net SBC as 300 kilonewton per square meter. So either you get this value from geotechnical report, or you can assume this, but you take the responsibility once you assume this SBC. And it should rest on hard strata. So the hard strata, once you excavate the footing, then you can get that idea. Where is the hard strata? Black cotton soil, if present, shall be removed totally. So see, generally in black cotton soil, there is a possibility that you get the soft soil or black cotton soil near the surface of the earth, or that ground level we can say. So, and there we also get hard strata below the black cotton soil. So please remove this. And soil strata shall be got approved prior to the placement of footings. So either geotechnical person or structural engineer approves the strata level. We don't do the footing without visit. Then lap length of column shall be 50 times diameter of the smallest bar. Okay. Do you know what is lap length? Lap length or development length, do you know? Generally it is 50 times diameter of the bar.
Yes, sir.
So here you can see this is the column reinforcement, and in this column reinforcement we are lapping here somewhere. So this length from here to here, we call it as a lap length. So there is a one point is lap length, or there may be development length. Both generally are taken 50 times diameter of the bar. Then in if the unsupported length of the column exceeds 3 meters, then tie beam shall be provided. See, many times what happens, you assume your unsupported length in model as a 3 meters. And there is a possibility that समझो ऐसे हो सकता है ना side पे. Now see, whenever you model this building in ETABS, what you are doing, you are assuming footing level. So मुझे ये आपका plinth level है, plinth. Say this one, ना? Then you are having supports over here. ये fixed support है ना हमारा. Then you are having first floor, second floor. So let's say this is your first floor, second floor, and plinth to first floor is 3 meter. First to second is 3 meter as per architectural drawing. And let's say you assume your hard strata is, let's say, at distance 2 meter, for example. Then you also model this footing here, supports in ETAB model 2 meters, and you design this column, this portion column for height of 2 meters, either RCDC or Excel, whatever software you use. But let's say you started the excavation and we found that our footing hard strata level is not 2 meter, but it is something 4 meters. समझो 4 meter पे है actually in reality hard strata. So what is happening here? Now your effective length is coming out to be not effective, unsupported length is coming out to be 4 meters, and you have designed the footing for 2 meters. Not footing, column, sorry. So you have designed it for 2 meters, and this is now L is 4 meters, and all of you know that once the length increases, slenderness increases, and if the slenderness increases, then moment will increase, and if the moment increases, then steel and sizes will increase. So that means your design of 2 meter column will not be sufficient for 4 meter column height, right? That means you should change the design. So this is first criteria. You can change the design, or you can add one more tie beam here, tie beam. Okay. Either add tie beam. Once you add the tie beam, then it will be 2 meter only, and this will also be 2 meters. So this way you can get rid of the redesign, or if you are not interested in providing tie beam, then design the column again for 4 meter height. So this way we do. So generally we are giving this standard note, but finally the decision is taken by the structural engineer that if unsupported length of the column exceeds 3 meter, then tie beam shall be provided. See, if by mistake we miss this point, at least the contractor should ask regarding this. Okay. Then cover to the reinforcement shall be as follows. Nominal cover. For columns it is 40 mm, for footing it is 75 mm. Slab it is 25 mm, 20 to 25. Beam it is 25 mm or 30 mm. So generally if it is a coastal region like Mumbai, near sea we can say. So generally we take the slab 25 mm, and in beams we take 30 mm. We need to increase cover little. Why we increase the cover in coastal region?
So because reinforcement get corrosion,
Yes, so the
durability decreases if
yeah, because
cover is less.
and in coastal region actually there is a humidity actually in the air. Humidity, and due to humidity means it is having a water. Humidity means water in the air, and the water will react
Yes.
with the concrete and reinforcement and will corrode the steel or deteriorate the concrete. So we generally increase the cover, let's say 5 mm. So it's up to you how you are putting this notes. And cover block shall be used. So see, as you are designing the reinforcement for beams, footings using effective depth, that means effective depth has to be there. So cover block shall be provided, and shuttering design is the contractor's responsibility. Generally, we don't take the responsibility of the shuttering design. If they ask us to design it, then and then we take it. Otherwise, it is his part. So there are limitations to our responsibility as a structural engineer. It is not that we are 100% responsible for everything. We are responsible for the design drawing. That's it. And there is a shuttering. All of you knowing this de-shuttering period is given in the IS code. So you can mention that. And work shall be carried out under the supervision of qualified and experienced engineer, and strictly as per the structural drawings. Please keep in mind, there has to be qualified engineers on the site who understand the structural drawings. And we are, see, Why we are writing this? Because we are not interested in taking unnecessary responsibilities of the site. Site people should take care of this. And it should be strictly as per structural drawings. So let's say you have given this dimension on site, on drawings, and that contractor has by mistake or by whatever reason, let's say he has done 200 means 100 the footing width length is short. You cannot accept this, because your design requirement is 2.1. It should be 2.1 on the site. So there should not be any discrepancy on site and on your drawing. Here, no water table not present. So these are the notes you should provide in the foundation drawings, and we also give the details of columns also in this drawings. So we give this plan of the reinforcement, and you can even give such kind of small detail also here, this part. As the columns are starting from the footing itself, that means you should give the details of the columns also in the drawing. So if you see the columns, let's say we are starting from the footing like this, you should give this smaller section in this with this EL of the column, and you should mention the lap length also. So where to lap the column bars. So generally, this lap. Okay, let me finish first this part. So we need to give the. So actually, this is the beam section. You can. There is no need of beam section in this drawing, ideally speaking. You're only interested in column details and foundation details in this drawing. That to column with only section here. Then give this standard section of the column and standard section of the plan detail of the column. And then we give the name. I'll come to this point once I start the column. And then see, sheet title block is very much important. So see, drawing is an authentic document. Please keep in mind. So it should be perfect, or there may be any problems in future if your drawing is not correct. Now disciplines means, let's say many times many companies are having different disciplines: architectural, structural, then it may be mechanical, electricals, plumbing, civil. So there are many disciplines in one company. So we may need to mention this, which is the discipline, or drawing is structural drawing or architectural drawing or mechanical drawing. Then there is one point which is nothing but drawing status good for construction. So there are different status of the drawing actually whenever we do this. See, many times our drawings may be for communication purpose only. Let's say I want to share this drawing to the architects for their review or for their discussion, we can say. Let's say I want to have a meeting with the architect, and for discussion I want this. So I cannot say that this is my good for construction drawing. Good for construction means if contractor gets this drawing, he will start the work without asking anything. He will assume that everything is correct and he will start the work. But there is a possibility that there are certain pending issues on the drawing. For example, let's say this is your plot layout or building outline, let's say, and there is some we can say the decisions are pending regarding the location of this column, because this building line is not clear from the architect point of view. Let's say there is some problem on the bylaws in municipal corporation. As per the building line or plot line, there may be issue regarding this column location. So what can I do? I can keep this column as a hold. Okay. So I can cloud this. I will cloud this first, and I will write over here in the AutoCAD as a hold. Hold means contractor will not do the work of this column. Okay. And let's say you can even send this drawing to the architect only for discussion. So you can write here as a discussion, for discussion only. You can write here as a for discussion, or you can say as advance copy only. Advance copy or for discussion means not for construction. It is only for discussion, meetings and all. Once architect gives the green signal to us, once the client gives green signal to us, then and then we say that it is good for construction. And once it is good for construction, you can construct on site using this drawing. Then whatever company you are having, you can mention the company name. Then the name of the project. Let's say it is a G+5 project. Oh, I'm just G+5 residential building. Let's say in Mumbai, whatever you want. Now, what is the title of the drawing? It is a footing layout and schedule. Okay. Footing layout and schedule. Getting this? So that means what are the contents in the footing layout and schedule? Footing layout, footing schedule, then section of the column, section of the footing, notes, and small details like this. So this is your foundation drawings. Have you got this? What are the contents in the foundation drawing?
Yes, sir.
And even you can copy.
Yes, sir.
ये भी copy कर सकते हैं. Actually वो होना चाहिए था. I don't know क्यों नहीं उसमें. You can do this. Section भी चाहिए so that the contractor will understand this. I say you can copy this. So ऐसे कर सकते हैं आप. Move this. कहाँ है वो? यहाँ डाल सकते हैं आप. Okay. So find the space, create the space, whatever you want, and then just do it. See, many times you need to, in drawings, it is an art actually, how to fit the drawing within the page and all these things. It is a tricky generally. Let me, अभी training के लिए मैं इतना ज़्यादा time नहीं. Okay. This is your standard section. Just put it over here. Now you get this. So you get the typical plan of the footing, typical section of the footing, so that by referring this schedule and these sections, the contractor can do the construction on site. Okay. So there will not be any questions. What should be this EL value or this hook length? What should be this EL for the column reinforcement and so on? Everything is on the drawing. There is no any ambiguity. And then along B means what? So you will understand along B is this. This transverse reinforcement is along B. I hope you got this.
Yes, sir.
Now, second part is the column. See, columns, we know that our building is, let's say these are the buildings. So where we start the columns, actually, we start the columns at the footing level. Correct. So we are having columns from footing level to the plinth level, then plinth level to the first floor level, then second slab level, like this. So here, this is my base, that is footing. Base to plinth, it's one column. So this is the construction sequence. We cast the column till the base, that is till the plinth first. Then I will cast the column from plinth to first floor level. Then I will cast the column from first to second level, as per the construction sequence. So what is the construction sequence? Anybody, please? First क्या होता है? पहले क्या होगा?
Cleaning the site.
Foundation.
Okay, we will do the excavation. I just want to go regarding RCC. So we will do the excavation, do the PCC first. Once you do the PCC, we will cast the footing. And in the casting, we will also have a column, don't forget. Then once you cast the footing, you will cast the column till this portion. Then you will cast the beams, plinth beams. So plinth beams are casted. Now then you will cast again the columns which are going till the first floor. So all the first floor columns you will cast. Once you cast the first floor columns, then you will cast the again floor slab and floor beam, right? So this is casted, floor slab and floor beams, and again the columns, again floor slab and beams. This is the construction sequence in general. So we are having different steps of the column, this, then this. So that has to be reflected in the schedule. And we know that as the load is maximum at the base, that means this is my maximum load for the column, then it will reduce here. So then again reduce here. So you know that minimum load is at the terrace. These columns are having less load because it is only carrying terrace slab load. Then it will add here. So you know that column load goes on increasing till the foundation. So terrace it is very less, and at the foundation it is very high. That means you can reduce the steel or sizes of the column as you go up. Getting this?
Yes, sir.
So the column size and steel will be more at the base, and as you go up, you can reduce it because there is no much load as you go above. So that's why we are giving the column schedules floor wise. So this is your column schedule. So there are C1, C2, all column numbers are there, and each and every column is given over here. So here you can see base to parking floor. Parking floors or plinth level, whatever you want to say. Then parking floor to first floor to second floor. So in between we are seeing first floor to second floor. So this is your column. Whenever it is written first floor to second floor, this is the column which I am talking about. Okay. Whenever I say second floor to third floor, this is my column. Whenever I say base to parking, this is my column. Getting? So this understanding is very much important. Many times I have seen the people are very much expert in handling the complex problems, but they do basic and conceptual mistakes or common sense mistakes. So it should not happen what you are assuming and what you are doing. So if you are taking the results of the ETABS here, then whenever you design, the design should be reflected here only, base to parking. Please keep in mind. So there has to be exact picture in front of you whenever you do design analysis, drawings and everything. See, we have seen a lot of blunders on site in our experience through contractors. बहुत बार ये गलत दिया, if you give this wrong, then they will do it wrong also, or they may assume something wrong and they will do it wrong. So many times it happens, they don't understand the schedule also. So if you are visiting the site, please educate the site engineer first. You should read this drawing like this. So these are the levels we are mentioning first. Fifth to terrace, and if there is a staircase cap, then you can add the schedule also over here. Now here you see number column label, column C1, and you will see this size of the column 600 by 230. Then there is a TOR 12 bars, 10 T12. 10 means number of bars, T is 12. T is TOR and 12 is diameter of the bar. So the bars location is mentioned over here in the section. And the links means stirrups. So there is a master ring, then there is one more hoop, and this is a link, cross tie we call it as. And the cover and grade of concrete and steel is mentioned over here. So as you go up, you can see this. Getting? This schedule you get in RCDC. So no need to prepare this. If you want to do this drawing in AutoCAD, it will take a lot of time actually. If there is no RCDC software, then preparation of column drawing is many times very difficult. It takes a lot of time. Fortunately, you are in the RCDC time. So this work is very easy in RCDC. whenever we used in our time, actually, we have done these drawings by using even tracing paper and rotary pens actually. So we used to do these details on drawing paper by pencil and rotary ink pen. Okay. So it was very difficult time in our say 20-30 years back. But nowadays this RCDC is giving within minutes this drawing. So, but yes, it doesn't mean that RCDC is very smart. You should check the drawings also. Please keep in mind. Verify the drawings whether it is giving correct or not. So we have a lot of this all column details. If the columns, now this is till C9. Now this A1 sheet fits only 9 columns here. Then you can go in the other sheet, and then from 10, 11, 12, 13, you can add columns in this sheet. Even though they are not fitting, then you can add other sheet like this. So many times we have a lot of drawings for columns also. You can see these hoops are different for different number of bars. If it is a 12 number of bars, then there are 2 hoops, 3 hoops, 1 master ring and 2 hoops. Do you know hoops and cross tie? Hoop means total stirrup. This we can call it as a hoop. Total stirrup like this. And this we call it as a cross tie. Technical term. Or we can say link. And generally, when it covers the total outer portion of the column, we call it as a master ring. These are the general names we use in practice. So for different numbers, it may be different. Let's say here we are having 10 bars. That's why there are 1, 2, 3. Here we are having 12 bars. So there are 2 hoops here. So it may be different. Even the numbers are more. Here you can see this is also. If the width of the column is more, then we can have such kind of triangular shape hoops. Okay. As this width is more. So this is the drawing of column, and you can write here in the title block as a column schedule. If there are many sheets, like we are having how many sheets for columns? So this is the lift wall details. So it is a part of column only, because lift also goes from base to the terrace level, right? So how many drawings are there for columns? 1, 2, 3, 4. 4 drawings are there. So here you can write here in the column schedule, you can write as column schedule, and below this you can write as a sheet 1 of 4. Because there are 4 sheets. 1 of 4. So what happens if on site there is many times we can say people are not organized on site. Many times I have seen. I'm not saying that all sites are like that, but there is a possibility that the drawings are not with them correctly. Let's say there are 50 drawings you have submitted. They are carrying only 30 drawings. And it may happen that he gets this drawing and he will say that where is the C10 column? So he will be confused. C10 drawings are not given by the structural engineer, and he will call them. See, he should check whether there are many other drawings or not. So if it is a sheet 1 of 4, that means he will understand there are other 3 drawings are available for column schedule. And that is the purpose of writing this sheet 1 of 4. Then this will be sheet 2 of 4. Second sheet out of the 4 in column schedule. And there will be sheet 3 of 4. Or if it is lift wall details, you can. This way we can. I'm emphasizing on this title block also because this is very important. See, unless you complete the title block, it will not be complete. Understanding. Now, let's say there is one point regarding the sheet title block I will mention. Say you have submitted this drawing to the site, and during the construction, let's say architect told us that I want this column size to be, or this column to be rotated in the horizontal direction, let's say. So during construction, means, let's say this column is not yet casted, all other columns are in progress, and this column is yet not casted, and architect told me that please change the orientation of this. For example, that means I need to change the orientation of footing. So what I have done here, I changed certain things. That means we call this as a revision. Getting? So this is my revision, and I will cloud this on the AutoCAD. I'm not, let's say I'm giving the cloud to this. And I will give the rectangle as a 1, R1. Okay, so this is revision cloud. Something is revised in the drawing, and R1 is the revision, first revision generally. So once you cloud this on the drawing, then you can go here and put the revision history. So there is some revision. So what can you do? You go press this here. Let me press this first. R1. So there is one revision. Then let's say I have revised it, let's say on 20th of August. Let's see. Who has drawn this? Let's say somebody is there, AS, who has drawn this. And what I have done, so there is a revision, we can say history, which footing C16 column and footing changed. So write down here C16 and FC16. Revised. There is some revision in this column, and then who had checked, let's say I have checked it and I have approved also. So this we call it as a revision history. So, and then once you write over here, okay, then you can send this drawing again to the contractor and put the cloud over here, Rev cloud. Let me. Let's say this is your cloud in the AutoCAD. And I will put the revision mark. We are having everything here, revision mark, revision cloud, and this. Revision 1. Getting this, and I will submit this drawing again to the site, and they will do the construction according to this. There is a possibility that again there will be some changes. Again, you need to add the revision history as a R2. Okay. And again, whatever changes are there, please mention that here, and just it may happen that in the project there may be a lot of revisions. See, general the process in larger projects, I am saying. For smaller project there is no much problem. There may be possible, but for larger projects there may be 10 to 15 revisions also. Please keep in mind. See, that means so many revisions are always there on projects. Larger projects, whenever I say, see, our work starts in the tender phase only. So there is a tender phase before start of any work. Then in tender phase also there may be 2 to 3 stages, one second stage, third stage. Then after tender stage we have a construction phase. Okay. Construction phase also there may be multiple revisions. 1, 2, 3, 4, whatever. So that means your drawing is going through a lot of revisions throughout the project till the completion of the project, we can say. So that's why there is a very much importance to this revision history table. And these clouds also. Clouds are also important to maybe mention on the drawing. Otherwise, contractor will not understand where is the change. So there, otherwise he will unnecessarily will find out the yes, isme hai kya kuch change, isme hai kya. So unnecessarily why to create confusion in them? Better way mention where is the change and just put this revision triangle and mention here what is changed here. Okay. So this is the importance of revision cloud. I hope all of you got overall idea about the drawing.
Yes, sir.
In the next
Yes,
session,
sir.
we will see in detail the column part, this column section in detail, and then we will go see this maybe lift wall and then floor drawings, plinth drawings, and all this. Okay.
Okay,
So
sir.
today I have given the idea about the overall layout of the drawings, the contents within the drawing, the title block, revision history, and all. See, this is very, very much important. And I suggest once you understand the design analysis and everything, please give more focus on the drawings. This is the final output. So it should go correct on the site. We will also discuss on the
Yes, sir.
the standard drawings. Maybe discuss करेंगे next session. Any questions?
No, sir.
सर ये जो करेक्शन आपने बोला क्लाउड वाला, सर ये एडोब वाले में करके देंगे या ऑटोकैड ड्राइंग में
AutoCAD में,
जाएगा?
ये AutoCAD में ही है. See, Adobe is only for communication with the people. It is not a, we can say, not for construction. Huh? We don't do
Okay.
construction on comments given on the Adobe. Please keep in mind. It is only for review. मतलब within the before construction जो भी होता है ना उसके लिए है.
Yes, sir.
The authentic document is this only. इस पे ही लिखना है हमें. You can write it, मतलब ऐसे नहीं बोल रहा हूँ कि ये possible ही नहीं है, but that is not the practice.
Yes, sir.
मतलब ये अभी ये मेरा drawing है and this is my Adobe. So I can write down here as a cloud. यहाँ भी निकल सकता हूँ मैं, but that is not practice. Huh?
So the final वो ऑटोकैड शीट पे ही जाएगा सर?
हाँ, AutoCAD sheet ही है and finally ये PDF बनाते हैं ना हम. PDF is only for communication before the construction.
Yes, sir.
मतलब मैं ऐसे बोल सकता हूँ ना, see it may happen that my architect is saying, so let's say I have sent this drawing to the architect. I know that once the architect gives me the permission, then and then I send this drawing to the site. So it may happen that architect is saying, so let's say I am architect now and I am putting this cloud. And then I will say here, oh. Okay, ये है मेरा. Rotate column. So I am architect. I am giving the comment on the structural drawing. So I will give this comment on the structural drawing, and I will send this PDF to the structural engineer. So structural engineer will understand that they want C16 to be rotated. So I will change the model. I will change the design, whatever I want, and I will change my drawing. And again, I will send the rotated drawing, which is this one, to the architect again. Once the architect approves that, I will send this drawing by giving the cloud to the site. Okay, getting this?
Yes, sir.
So that's
Now
means
it's clear.
yeah, so I'm using this only for communication with architect and other people. Once the communication is over, once the change is done, change will be done in the AutoCAD drawing with relevant clouds and whatever. And this drawing I will do the PDF and will send to the site for either PDF or say printouts. Got it?
Yes, sir.
Yeah. Okay. Any other questions?
No, sir.
Okay, so we'll conclude today's session and we'll meet maybe day after tomorrow or tomorrow. Let me check it out, schedule. Okay.
Okay, sir.
Yes, sir. Thank you, sir.
Thank you.
sir. Good night,
Thank you and
sir.
good night to all.
Good night, sir.
Good night, sir.